Hello, very good evening students. So let us start about set theory. I'll be teaching you set theory from basic level to the advanced level. So before solving the problems on the set theory, which is of up to JEE mains and advanced level, so let us see minimum basics of a set, how set is represented, how the elements in the set is represented, what are the types of a sets, right? So let us move on to our actual topic. What is meant by set? We already know that set is nothing but a well-defined collection of distinct objects here. So can you tell me what is meant by a well-defined? We already know that well-defined is nothing but unique representation, unique interpretation. So if you want, I can give you an example. So I can say that if I asked you which is your favorite subject, what will be your answer? Favorite subject for me, let us assume I like chemistry, physics, science. Agree? So if I ask you some other person, he may say that he likes maths, Telugu, right? So according to the question is same for both of the students, but A student said that his favorite subjects are chemistry, physics and science, and B student said that his favorite subjects are maths and Telugu, right? So here set is not well defined. Why? Because it is with respect to one person set is different, and with respect to the other person set is different, so this is not a well defined. Agree? So we can say that when can I say set is a well defined, it should be of unique representation, right? So actually we will be denoting set with what? Capital letters. So I have denoted set this with a capital letter A, and this one I have denoted it what? Capital letter B. Agree? And inside the set I have taken some elements now. So instead of this C, I can write it as a chemistry, or I can write it as a physics. So what we will say, we will call this as the elements of a set. Agree? So let us see what is meant by elements of a set. What is meant by, how can I represent element of a set? Always elements of a set are represented with what? Small letters. So I can take A is equals to A, E, I, O, U. What is this? This is a set which contains the vowels. Agree? Right? Here I can represent this in the small letters. So now let us see how the set is represented. How can I say the set is represented? So actually set is represented in how many ways? Two ways. One is what? Tabular form, or we will call it as enumeration method, and the other one is what? Set builder method, right? So this is actually divided into two types, right? So what is meant by enumeration method or tabulation method? Let us assume if I have any set, if I write this set within the flower brackets, right, which each and every element in the set is separated by the commas. So what I can say, let me take 1 2 3 4. Agree? So what I can say, this is a set, right? And the same set I can actually rewrite in the form of A is a set such that I can take X, such that X is a natural number, and I can take that X is less than or equals to 4, right? So if anything that can be written in the format of a properties, agree, stating the properties, we will call it as a set builder form. Anything that we will be rewriting that in the braces, we will call it as a enumeration method or tabulation form. Any doubts up to here? If you have any doubts, you can mention in the chat box. Okay, so now let us move on to the next type, right? So there are some remarks before going to the into the types of assets. There is a some remark. Let us see what is that remark. So if I take a set A, if I take it as 1 2 3 4 5 6, 1 2, so is it a set? Obviously it is a set. Why? Because it is well defined, and what I said, it is a well defined collection of distinct objects. So which means that objects 1 is repeating twice, 2 is also repeating twice, so this should not be there. Actually I can rewrite this as A is equals to 1 2 3 4 5 6. Agree? Are you getting my point? Also, I can also rewrite this set as 6 5 3 2 5 1. Agree? So what is the meaning? Can I say these two sets are same? Yes, I can. Why? Because it is immaterial. Immaterial means order is not important. What is important? Elements in the set is important, right? So here we are having 1 2 3 4 5 6. Here also we are having 1 2 3. Here 4 is missing. I am so sorry. Let me rewrite. This is not a 5. This should be a 4. Okay, so let me rewrite this one. This is a 4. Huh. So this is a 4 5 6. Agree? So these two are the sets. That is what I have written. So I can say that the order of a writing a set is immaterial, so there is no importance of the order. So ABC is same as a BAC, which is also same as a CAB, which will denote the same set. Agree? And also one more thing I already said, say in the set elements are not repeated. So actually this is not the correct way of writing a set. This is a way of writing. Agree? If you have any doubts up to here, you can mention. Okay, So now let us move on to the some properties. What is that? Some standard sets. Before going to the topic, let us assume what is meant by natural number. Natural number, I can denote it with a capital N. Agree? So what are the natural numbers? Any counting numbers, right? Like 1, 2, 3, 4. They are known as what? Natural numbers. Agree? And we already know these are the basic things. What is a W? W represent a whole numbers. What is meant by whole numbers? The counting numbers along with 0 is known as a whole numbers, right? So now let me check what is that. This is an integer. So I can say integer can be denoted with what? It can be denoted with z or I. What is meant by integers? The counting numbers along with 0 and the negative counting numbers. Agree? So which is nothing but this is from minus infinity and so on up to minus 3 minus 2 1 and so on up to infinity. So this comes under the case integers. Agree? So what is meant by z naught? If you check this clearly, there is a base like z naught. What is this? Z naught represents the, this is what naught means what? This is 0. So from the whole integers, I have to remove the 0. Okay, this is the notation we need to use. Agree? In the whole chapter, I'll be using the same thing. You can check it. Okay. So z naught and I naught. I is an integer, z is also an integer. What is the meaning of that? Excluding 0. So I can take all the integers. I have to exclude the 0 in this case. Agree? And what is meant by z plus? Plus represents, yes, you can guess it. Plus represent a even numbers, positive, not even numbers. It should be positive numbers. Agree? What is the meaning of z plus? I have to take all the set of positive integers. And if I take z minus, what is the meaning of z minus? I need to take set of all negative integers. Agree? So now even numbers came. What is E? If I take a E denotes what? Set of all even numbers. Even number starts from 2, 4, 6, 8 and so on. Agree? Similarly, O represent what? Set of all odd numbers. Agree? So now let us move on to few more. So we already know that what is meant by rational number. Rational number I can denote with the Q. Agree? So any number of the form P by Q where Q is not equal to 0, and what I can say? I can say that P and Q should be what? Should be an integers. This is known as what? This is known as a rational numbers. We will be denoting with Q. What is Q naught? As I already said, Q naught means what? I have to remove the 0 from the number. Agree? Here also what is Q naught? Q represents a rational number. Naught means what? 0. So we need to remove 0 from the rational numbers. Agree? So X is such that X is a P by Q where P and Q are integers and P is not equal to 0. Q also should not be 0. Agree? So can you tell me if I ask you a question, if Q is equal to 0, what it will be? It will be not defined. Anything by 0 will be what? It is not defined. Agree? Yeah. So what is meant by Q plus? You can guess it. Q plus denotes what? It is a set of all positive rational numbers, but I have written P and Q. It can be both positive, it can be both negative. But you can ask me, ma'am, you said Q plus is a positive, but you are taking both positive, both negative means, so P by Q, if I take both as a negative, so minus 3 minus 2, from this what I can say? Actually I can cancel minus minus, this will become 3 by 2. Agree? So either I can take both positive, that is PQ, or either I can take both negative, that is PQ. Agree? What is our, or is nothing but what? Set of all real numbers. We already know that, right? What is R naught? From the real numbers we need to remove the 0 from that. R plus means positive real numbers. What is R minus Q? From the R you need to remove the all the rational numbers. So we have a specific name for that. What is that? That we will call it as a irrational numbers. Agree? Now comes this one. This we will call it as a complex numbers. I can denote with C. How complex number will be represented? Complex number will be represented in such a way that A plus IB, where A and B are what? A and B are the real numbers. Agree? And what is I? Iota. We will call it as a iota. Some we will call it as a I. Agree? Which is nothing but square root of a negative one. Okay. So this is nothing but what? Set of all complex number. Whenever if you see Z plus, what it represents? Positive integers. So whenever I will be taking in the questions, it represents the same thing. You need to note it from this. Agree? Let us move on to the next. What is C naught? Actually, you can guess. What is C naught? From the complex numbers, I have to remove the 0. What is 0? 0 means I have to, A should not be 0 and B also should not be 0. Agree? Are you getting my point? Yeah, sorry, let us move on. What is NA? This is, I think this is a new notation for you people. So yes, then NA means natural numbers. A denotes what? Set of all the natural numbers which is less than or equals to that number A. Agree? I think these are the minimum basics which will be helpful for us. Agree? If you have any doubts, you can ask me. So now let us move on to the types of sets. So now let us start with the first set. what is the first set here given? This is a null set. So the another name for null set is nothing but what? Empty set, or we will call it as a void set. Agree? So you can guess what is meant by null set. If a set which does not contain any element, means there should not be no element in the set, we will call it as a null set. Agree? Or null or void set. It can be denoted with what? So the empty, this one. Agree? Any doubts up to here? Or you can denote this with 5. This is not F, this should be 5. Agree? This is known as a null set. Agree? So if you want an example, let me take an example here. If I ask you, can you tell me the number which is natural number which is less than 1? Is it possible? A natural number which is less than 1. A natural number which is less than 1. Is it possible? No, right? Which is less than 1. Just a second. So it is not possible. So what I can say? I can say that this does not exist. Which means what? So our set will be what? Empty set. So I can take A will be 5. Agree? Any doubts up to here? You can also give many of the examples. Agree? So I can ask you, can you tell me the month which contains 32 days? Can you tell me a month which contains 32 days? Obviously, no month will be containing 32 days. Agree? So months will be containing 28 days, 29 days, 30, 31 days, right? Any doubts up to here? Yeah. So now let us see some remarks. What is the remarks? So we will call 5. 5 is known as a null set. I already said, no, this is the notation or the representation. Always 5 will be unique. Agree? And we can say that 5 is a subset of each and every set, because every set will contain one non-empty set. Agree? That is a 5, right? So 5 never, so I can't write this as a 5. Why? Because so this both this is also 5, this is also 5. We should not represent this 2 in this format. This is wrong. Agree? And also, can I take this as an empty set? You can ask me, ma'am, you said empty set. I'll be taking 0 because 0 is empty number. You can ask. So this is not true. Why? Because in this we are getting one element which is inside, that is 0. Agree? What I said? What is meant by empty set? A set which has no element. But here having one element, it can be 0, but we should not get any element, right? So this 0 is not a what? Void set. Any doubts up to here? Right? So now let us move on. If you want in the, you can, okay, fine. Let us move on. I have given 2 examples. If you have any doubts, you can ask. So let us see what is meant by singleton set. You may guess. If you take any set which contains only one element, so now I can take a 0. Agree? So you can ask me, yeah, any set which contains only one element, that is what I have written. Agree? Is called a singleton set. Can you give me the set which is a even prime? Even prime is nothing but what? Only 2. Only 2 is the even prime number. Is it okay? If you have any doubts in this, you can ask me. Or what I can say? I can say that I can take one more example, such that I can take x, such that x minus 3 is equals to 4. So how can you say this is an singleton set? If you solve for further, so if I take this one, what is this? Always I have to take the x which is equals to x minus 3 equals to 4. From this I can say what? X is equals to 7. So 7 is the only value which will satisfy this condition. So I can say that answer will be 7, which is a singleton. Is it okay? Any doubts up to here? Yeah. So now let us move on. What is meant by subset? We already know. Okay, fine. Let me read the definition, or if you want, I can give with an example. So let us consider a set, that is 1, 2, 3, and let us consider the B set. What is that? 1, 2, 3, 4, 5. Agree? What is meant by a subset of B? If every element of set A is an element of set B, then A is called subset. A is called a subset of B, right? So if every element, here I can say 1, 2, 3 is there, here also 1, 2, 3 is there. Every element of a set A is contained in every element of a set B. We will call it as what? A is a subset of B. Agree? So this is a notation for subset. We will read it as a subset of B, or I can call it as a contained in B. Agree? Any doubts in this? So there is a one representation. Let me check. A is subset of B means what? If I take any element in A, obviously that element should be present in what? It should be present in B. You can cross check here. I have given one example. Agree? Also, I can say that there is a one remark for that. What is that remark here? I can say that A is subset of itself. Why? Because each and every element of A will be contained in each and every element of A alone. Agree? So that I can say that every set is a subset of itself. Agree? And also I can say that A is subset of B. and B is subset of A. So what I can say, A is also subset of C. Agree? So let me give one example so that you can understand easily. Let me take A. A is 1, 2, and let us take B. B is what? 1, 2, 3, and let us take C. C is what? 1, 2, 3, 4. Agree? So now try to look into this screen. So what we are having, each and every element of A is there in set B. Yes, we have. So I can say that A is subset of B. Let us check B and C. Each and every element of B is contained in C. Yes, we have, right? 1, 2, 3, 1, 2, 3. So I can say that B is contained in C. From this, what I can say? I can say that every element in set A is also contained in set C. You can cross check. Here I am having 1, 2. Here also I am having 1, 2. So I can conclude that A is subset of C. This is the conclusion. Any doubts up to here? Okay. Yeah. So now let us move on to the next definition. What is my total number of subsets? See, in this problem I have taken A. Let us take the previous example only, which is 1, 2, 3. Agree? So what I can say, can you tell me what are the subsets? Can I take, let us assume some A1. A1 is what? 1. Agree? If I take, can I say A1 is subset of A? Yes, obviously, na? Because every element in A1 is contained in A. So can I take A2 as 1, 2? Yes, I can also say that A2 is also subset of A. Agree? So can I say A3? Let me give you 1, 3. So can I say A3 is contained in A? Obviously, I can. It is contained in A, right? You can ask me, ma'am, how can you check how many are there? How to know? So there is a one formula. What is that? If you have a set A which contains what? N elements. Can you tell me number of elements in set A? Number of elements. This is the notation for this. Number of elements in set A is what? 3. 1, 2, 3, right? Then what is the number of subsets formula? Number of subsets is denoted with 2 power of n. In our case, what is n? N is 3, right? So which is 2 cube, which is 8. So we will be getting 8 subsets. Agree? So this is a specific name for that. I'll let you know in the next slide. That we will call it as a power set. Agree? That is in the next slide. Don't worry. So if you want, I can tell you what are the subsets. 1 is a subset, 1, 2 is a subset, 1, 3 is also subset. Also, I can say that 2 is a subset. Also, I can say that 3 is a subset. Also, I can say that I have taken 1, 2, 1, 3. So 2, 3 is missing. Let us take 2, 3. Also, can I take, I already said every set is a subset of itself. So I can take 1, 2, 3 also, right? So now you can ask me, ma'am, you said 8, but if you count it here, you are having 7. See, 1, 2, 3, 4, 5, 6, 7. Where is one more? If you remember correctly, I said that 5, that is empty set, is a subset of every set. So that is the next one, that is 8. Are you getting my point? So these are all the subsets of set A. Any doubts on this? Is it okay? Yeah. So now let us move on to the next. What is that? Equal sets. What is meant by equal sets? When can I say two sets are equal? Let us take a set, which is 1, 2, 3. Let us take a B set, which is 3, 2, 1. Agree? Let me write it as 1. So two sets A and B are said to be equal. When can I say? If every element of set A is an element of set B. Agree? And if means what? A is contained in B. Agree? Because each and every element in A is contained in each and every element in B. Agree? And also I can say that B is also contained in A. Why? Because each and every element in B is also contained in A. Agree? So if these two cases will applicable, then what I can say? I can say that these two sets are equal. I'll be representing it as a equals to B. So you can take it as a formula, take it as a granted. Agree? So if A is subset of B and B is subset of A, agree? So from this what I can conclude? Therefore I can conclude that A must be equals to B. This is the formula, you can note it down. Okay? Any doubts up to here? We'll call it as a equal subsets, right? Yeah. So this instead of therefore, so let us use a symbol if and only if. If I say this, A is subset of B, B is subset of A, if and only if A is equals to B. So both the sides, you know, right? What is the meaning of this? If I take left hand side, we'll be getting right side. If I take right hand side, we'll be getting the left side. Any doubts up to here? Yeah. So now let us move on to the power set. What is meant by power set? Before I said the total number of sets. So let me give you here. So if you take all the subsets of a set, That is known as a power set. You can read the set of all subsets of a given set is known as a power set. We'll be denoting with the power of a. We will call it P, means power set of a, right? What is the formula? 2 power of n or 2 power of a. A is nothing but number of elements in the set. Agree? So yeah, I think I have given you example also. No doubts in that, right? Yeah. So now let us give some properties of the power set. We can say that power set will contains obviously phi and a also. Agree? Both are elements of a power set. Yes or no? Right? Any doubts in this? Yeah. So now let us move on to the next here. Just a second. Yeah. So what is meant by superset? So let me give you one example so that you can understand. Let me take a set A. So what is set A? 1, 2, 3. Agree? What is set B? Set B I have taken it as a 1, 2, 3, 4. Agree? So I can say that each and every element in set A is in what? Set B. So we already seen that A is subset of a B. Agree? So the statement A is subset of a B, we will read in this way. The same thing, can I write it as B is like this? What is this like this? Like this means this represents a superset. This is symbol for superset. Agree? Right? So this is nothing but B is superset of A and we will call it as a superset. Nothing difference here. If you rewrite in this way, this is subset. If you rewrite in the opposite way, that we will call it as a superset. Is it okay? Yeah. So now let us move on to the proper subset. What is meant by proper subset here? Yeah. So let me take an example so that you can understand easily. So let us take 1, 2, 4 and let us take a B set which is 5, 1, 2, 3, 4. Agree? Huh. So A, if you take each and every element in set A will be contained in set B. Also, there should be one extra element in set B which is not in set A. Agree? So let me give you. Here I am having 1. Here also 1. What about 2? 2 is also there. What about 4? 4 is also there. What I am telling? See here. A set A is to be a proper subset of B. When can I say? If every element of set A is an element of set B, that is done, and B should have extra at least one element. This is very important. Agree? So B should have exactly at least, not exactly, at least one extra element. It can be 1, 2, 3, whatever it may be. Agree? So here I am having two extra elements, obviously, right? So I can say that A is a proper subset of a B. Agree? Any doubts in this? So you can ask me, ma'am, what is the difference between then subset and the proper subset? If I have a that is 1, 2, 4, let us assume. If I have a B, let 1, 2, 4. Agree? So what I said, if each and every element in A is contained in each and every element in B, so this is known as a subset. Agree? So it may have what I can say extra elements, but we never mind. Agree? So in specifically for proper subset, there should be at least one extra element. Agree? Here also you can have, but actually we should not. We did not check. Are you getting my point? Obviously they should have some extra elements. Any doubts up to here? I think everything is. Did you understand, right? So basically, what we want we want any elements which is not in A. Agree? 3 and I can call it as a 5 does not belongs to A. Yeah. So I need to introduce what is this? This belongs to. So if you take any set this is a set. The A is a set. In that I have taken elements. I already said elements in the set will be represented in this way. Agree? Actually, I can take one belongs to A. Why? Because this is an element which is in set A. I can also say 2 belongs to A. Agree? So I take 3 belongs to A. 3 is there in the set A. No, right? So this is not belongs to. This is does not belongs to. Agree? So I should get at least one or two elements which is does not belongs to A, but it should belongs to B. This is symbol belongs to. This is does not belongs to. Are you getting my point? Any doubts up to here? So if you want some random example means I can give you natural numbers is what? A is proper set of what? Integers can I take? Why? Because all natural numbers will be there in integers and integers will contain extra. What is that? 0, -1, -2, on so on what? Negative infinity. Can I take integers is proper subset of what? Rational numbers. And also we can take that rational number is proper set of what? Real numbers. Agree? And real numbers is proper subset of what? Complex numbers, right? So if you want in detail about complex numbers and all, we will be moving on in next classes. I will let you know. Okay. So any doubts of the proper subset? No, right? Yeah. Now let us move on to the next definition. What is that? Finite set. You can answer this easily. What is this? If you have a set, let me take same 1 to 3. Let us see. Don't feel like I'll be taking same example for each and everything. This is the easiest example, so you can learn each and every formula. Agree? Yeah. So if I take a set A, right? So number of elements in this. How many elements are there? Number of elements in set A is how many? There are 3 elements, right? So this, if number of elements in a set A is finite, which we can count, we will call it as a finite set. Which is not, we are not able to count, we will call it as a infinite set. You can check the example here. See here what I have written, not an example. Definition: a set in which process of counting elements comes to an end means if you can count it, obviously it is a finite set. Whether if you are not able to count it, it is what? It is an infinite set. Yeah. Any doubts in this? Yes. So if you want, I can give you one example here. Agree? So set of all natural numbers, which is less than 10. Agree? So I can give set of all natural numbers which is less than 10. This comes under what? It comes under finite set. Also, I can give you one example for infinite set. What is that infinite set? Set of all natural numbers simply. Why? Because we don't know how many natural numbers are there. Are you getting? N denotes the natural numbers. I already said you, right? Any doubts up to here? Is it okay? Yeah. So now let us move on to the next step. What is meant by this? Cardinal number of a set. So what is meant by finite set? If the order is finite, that is finite. Agree? So if you take number of distinct elements, simply the order of a set. Agree? Cardinal number means what? The number of distinct elements of a finite set is called a cardinal number. Nothing but order. Okay. So nothing to worry about it. So if I gave you a is equals to, let me give you -1, -4, 0, 1, 2, 3. So what is the n of a? N of a means order of the set, or you will call it as a cardinal number. So how many are there? 1, 2, 3, 4, 5, 6. So answer will be 6. Any doubts up to here? Yeah. Now let us move on to the comparability of a sets. What is meant by comparability of a sets? So when can I say two sets I can compare? If A is subset of B, or if B is subset of A, or if A is equals to B. If they have any of these three relation, so that I can compare. So let me take 1, 2. If I take B is equals to 1, 2, 3. Agree? So in this case, what I can say? A is completely contained in B, a proper subset. Agree? So but B is not contained in A, right? This is not contained, and A is also not equal. Any of the one thing, right? So I can actually compare. Why? Because A is contained in B. Are you getting my point? Agree? This is a proper subset. Any doubts in this? Yeah. So what I can say? I can say that they are comparable. Agree? Now let us move on to the universal set. So if this will be taken with the help of an example only. So now let me give you AEIOU. What is AEIOU? These are the vowels in the English alphabet. So what can be my universal set? Let me denote with U. Why? Because there is a symbol union. You will get confusion. This is a universal set. Let us assume. Okay. So I can take what? All alphabets in English. Agree? All alphabets in English. I can take it as what? Universal set. Are you getting my point? Means this is a, let me read the definition here. All the sets under consideration are like to be subset of a set. Means this is a big set in which each and every set what you are taking should be contained in this. Are you getting my point? So I can take set B as H, I, J, K. Agree? This is also what? Subset of this one. Agree? This is known as a universal set. Any doubts in this? In mathematically, if you want an example means I can give you. So I can take the universal set as integers. Agree? Right? And what is our set A? Set A I can take it as what? Even numbers. Are you getting my point? Even numbers means 0. I can take plus or minus 2, plus or minus 4, and so on, right? I can say that A is a subset of U. U is a universal set. Are you getting my point? Yeah. Yeah. Let us continue about the union of set. What is meant by union of a set? Let us take a set A. So let us take some elements which is 1, 2, 3, 4, and let us take a set B which is nothing but 4, 5, 6. What is meant by union? Union, see, union symbol is U. You can represent it. It starts with U, so take U. Okay, this is a simple notation. Okay, so I can write it as a union B, means I have to take all the elements either in A or either in B or in both, right? So first of all, let us take all the elements in A, which is 1 2 3 4, and come to the B, 4. 4 should I write? No. Why? Because I already said, right, it is a well defined collection of distinct, means 4 is already taken, nothing, no need to take. So this will be 5 and 6. Agree? Any doubts on this? So you can check the definition, which is nothing but it should be either in A or either in B or in both. So we will call this as what? Union of a sets, means, or A union B. Is it okay? Or you can denote A union B with A plus B also. You will be read it as A cup B or A join B. Agree? These are notations. One author will be using one thing. So I have given to you whatever the book you are preferring, you can go with it. Okay. So what is the meaning here? Yeah, so I have written the same thing in which form? What is this form? This form I have detailedly explained. I already told you representation of a sets, right? So this is nothing but what? This is nothing but a set builder form. Agree? Set builder form. What is the meaning here? What is the meaning of A union B? I have to take all the elements in X such that X should be either in A or X should be either in B. So union, this is a union, or you can call it as a V. Okay, so this is a representation. I can write uh, or union or V. Any doubts on this? Is it okay? A union B, yeah, this is the symbols or the notations, you can cross check. So if I take one element in A union B, what is the meaning? Either that element can be in A or that element can be in B, or it can be in both. Agree? Any doubts up to here? Yeah. So now let us move on to the intersection of a sets. What is meant by intersection of a sets? Just now we have seen union. Let me show you what is meant by intersection. If I take a set, which is 1 2 3, if I take a B set, which is 3 4 5. So what is meant by intersection? Intersection means this is a symbol for intersection. Agree? So A intersection B is nothing but I have to take the common element, which is common in both. Which is a common element? Here I can say 3 and 3. So 3 is the common element. Are you getting my point? You can read it here. So elements which are common in both A and B. Is it okay? So what is how can I represent? In set builder form, X is such that I have to take elements in A and B. What is and here? And represents what? Intersection. Is it okay? Or you can call this is the symbol we can use. Is it okay? Or this is a symbol, this is a notation I have taken. So if I take a one element in A intersection B, obviously that element will be there in A, also that element will be there in B. Any doubts up to here? Did you understand, right? This is the example. Agree? Yeah. Now let us move on to the disjoint sets. Yeah. When can I say two sets are disjoint? Let me give you an example. If I take a sets 1 2 3, if I take the other set, which is 4 5 6. Agree? So whenever if I take intersection of the sets, is there any intersection? Means intersection means what? Just now I have said, which is the common element. Is there any common element? No, right? Whenever if there is no common element, no element means we will call it as what? Empty, means 5. Agree? The simple definition. What is the definition? If you have a two sets A and B which have no common element, means the intersection should be 5, then we will call it as a what? Disjoint sets. Here A and B or the disjoint sets. Is it okay? Yes. Now let us move on to the difference of a set. Okay, what is meant by difference of two sets? Let me take set A, which is 1 2 3 4, and let me take set B, which is 4 5 6 7. Let us assume. What is the meaning of A minus B? I have to take, you can see the definition here. You need to take set of all those elements of A which does not belongs to B. So let us what is the meaning here? I need to remove all the elements which is there in the common. So 4 is the common. Yes, try to remove it. What we need to take? We need to take the set of all elements of A which does not belongs to B, means so the remaining elements of A. So this will be 1 2 3. Agree? So this is nothing but we will denote it as difference of sets A minus B, and you can call it there is a representation, you can denote with A slash B or A minus B. Is it okay? Means what? I have to take X such that X should be in A and intersection means and, right, and X should not be in B. Is it okay? That is how I should take the element in the difference of a sets. Agree? Any doubts in this? Yeah. And you can ask me, ma'am, what is B minus A? Can I take B minus A? Yes, you can. What is B minus A? I have to take all elements in B which is not in A. Means what? I have to remove the 4. This will be what? 5 6 7. Is it okay? If you have any doubts, you can ask me. Okay? If I'm going too fast, you just let me know. If you did not understand any concept, let me know. Okay, I'll go according to that. Now let us see what is meant by a symmetric. So there are maybe only this and the next two definitions are there. Let us conclude. Okay. What is meant by symmetric difference? You can check. Before I told you what difference between. Now what is this symmetric difference? What is meant by, there is a definition. What is meant by symmetric difference? I'll denote with a del b, or I can denote with a, this we will call it as a direct sum. Okay, this is a notation or the representation for the symmetric difference. We have a formula. What is the formula? We have two actually. What is that? It can be written it as a minus b union with b minus a. I told you how to calculate a minus b and how to calculate b minus a, and take a union of that. And there is a one more formula you can take. What is that? You can take a union b minus a intersection b, nothing else. It is simply a formula. Is it okay? That is what I have written here. Any doubts up to here? Is it okay? If you want an example, let me give you an example. Let us take a set which is 1 2 3 4 5, and let us take a b set which is 1 3 5 7. Okay. So what is a minus b? A minus b means I need to take an elements which is not in b, right? I need to take elements from a which is not in b. So let me cancel the common. 1 1 is common, 3 3 is common, 5 5 is also common. So a minus b will be what? It should be 2 comma 4. Then what about b minus a? I have to take elements from b which is not there in a, means only 7 is there. Is it okay? So then what happened to a? Symmetric difference of a b. The formula is what? A minus b which is 2 comma 4. Agree? Union with 7. You know what is meant by union? You have to take the all the elements which is there in e and which is there in a and b. Agree? Both. Agree? So the answer will be what? 2 4 7. Any doubts up to here? Is it okay? Yeah. So now let us move on to the complement of a set. What is meant by complement? You can see, I already told you. What is this u? U is nothing but a universal set. I already taught you, right? So if you have a universal set, if they asked you, let me give you universal set as, let us take 1 2 3. Okay, 2 is missing. Just a second. Yeah, so this will be 1 2 3 4 5. Let us up to 5. A is a set which is 1 2. Agree? What is meant by universal set? You need to take the elements of which is not there. Yeah, okay, fine. Let me give you here. U is a universal set. Agree? So I have to take the complement. We will call it as a complement of A. Agree? Means I need to take a complement is nothing but U minus A. Simply you need to take the elements in the universal set which is not there in A. Agree? So I'll denote with a complement or a dash. Agree? Or I can say U minus A. What is the thing here? This is 1 2 3 4 5 minus A. A is what? 1 2. So what is the minus? I already told you, difference. I need to remove the common elements. I need to take the rest of the elements in the first set. That is what? 3 4 5. That is what I have written here. The complement of A. Is it okay? U is a universal set such that A should be contained in U. Then this is known as a complement. Any doubts up to here? Did you understand? Yeah. So this is the notations what I have taken. So what I have to take all such elements. X should be in U. Agree? And X should not be in A. This comes under what? This comes under universal set. Is it okay? Any doubts up to here? Yeah. Thanks for today.